So one of the things that we talked about yesterday when we were building up the Raspberry Pi computer is we mentioned an operating system. And so in this lesson, what we're going to do is talk a little bit about an operating system and what it is and how it's different than other programs that that you probably use every day. So the first thing I guess that we should start with is talking about applications. So when you log into your telephone and you pull up your dial pad and you start dialing a phone number, that is an application that a programmer wrote to be able to interface with the hardware on the phone and dial the telephone number. And so all of these applications, your telephone application, your address book, your your texting application, all of those things are individual applications, and they all take a programmer, or in most cases multiple programmers, to make those things work. So you end up with an application, a bunch of programmers, and a bunch of source code just to be able to text message your friends and send them a smiley face. So that is an application, and those are programmers. But the problem that you get into is how is the phone app, the application that you're running to dial your phone or to text your friends, how is it going to work on the hardware on the phone? So we have software, which is what we write in code, and then we have hardware, which is the computer, in our case a Raspberry Pi. So how does that application that I write know what to do with the hardware itself? Because it would be really, really difficult if I was going to write a chat app on my phone, and instead of focusing on running the application and saying I have a text field here and I'm going to type here and I'm going to have a keyboard pop up, instead of me doing that, I have to instead write code to talk directly to the cell phone company and directly to the hardware that's on this phone. And if you imagine, there's a bunch of different phones. So in the Android world, there's a whole lot of different phones. In Apple, you've still got multiple phones because every year they come out with two different versions and three different sizes, and every single one of those are different hardware. And so to ease the process of being able to write an application and not have to focus on the low level hardware stuff, there's a whole bunch of other programmers that learn how to interface to the hardware, and they're not interested in writing a telephone application or a chat application. They don't care anything about that. What they want to do is to be able to write an operating system that runs on the hardware and talks to all the hardware that's in that computer, and the software programmers that come along and write a telephone app or a chat app or whatever, it will run inside of their operating system. So when you turn on your Windows computer and it boots up for you to log in, Windows is the operating system. All of the things that go along with making Windows work at that level, that's operating system level stuff. Sending something to the printer, interfacing with the screen, the monitor, your keyboard, being able to talk to the computer, all of that stuff is all working as part of the operating system. And then when I come along and say, well, I want to write a Windows application that can play a video game, well, now I'm focused on my video game and how to write the program around the video game, and I'm letting Windows take care of sending my game to the monitor, making the keyboard work, and all the other things that go in. So an operating system is extremely critical to any piece of hardware being able to work. Without an operating system, nothing is going to really work unless you're designing an operating system and you're making things work at that level. So operating systems, very, very important, and it's the key to making the computer do something. Now, there's a number of different kinds of operating systems. We have Windows that we just mentioned. We also have Apple. They have their own version of an operating system. And then you have Linux. And Linux is probably the most significant out of all of them because Linux was actually written for free by a bunch of programmers all over the world. So it's probably the largest software undertaking ever created because so many people are involved in this process to make Linux work. Where Microsoft and Apple hire developers to do these things, in the Linux world, they're relying on people to get off work and sit down at their computer in the evening and pump out code to make a new video card work, or to make them a new mouse that Logitech has come out with work properly. So there's a lot of things that go on, and Linux is the free version of Apple and Windows. Now, Apple's worth talking about for a minute, because where Windows went out and created their entire operating system all on their own, and it's, all they pay developers to do all this stuff. Apple was doing the same thing for a long time, and then back in the many years ago, Steve Jobs decided that they were going to switch over to a Linux based kernel, which means that Apple and Linux, while they're not the same, they have different graphical interfaces, and you're going to learn all this stuff as we go through, but they have different graphical interfaces and different ways of talking to the hardware a little bit. But as a whole, Apple is very, very similar to Linux. So the things that you're going to be learning in Linux, like opening up a terminal and doing some of the other stuff that we're going to be learning, you can pull right into Linux, into Apple, and do the exact same stuff. The same commands work, the same processes. I mean, there are differences. There's a lot of differences, but as a whole, they're very similar to each other. So Apple and Linux, even though Apple pays developers to work on their stuff, they do borrow a lot of stuff from the Linux community to make the Apple operating system. So learning the Linux, the Raspberry Pi, you'll see a lot of similarities between the two. So the key element to take away from here is that without an operating system, a computer would just be a hunk of metal sitting on the floor, because there'd be no way to get it to do anything. So at some point, someone has to come in and program things to do, the turn on the monitor or turn on the keyboard or whatever it is. Somebody's got to come and write a driver to make that stuff work, and that is the beginning of an operating system.